Welcome back to my channel. Today we're going to be doing another algorithm from Freecodecamp.org, and the one that we're going to be looking at today is this Pig Latin one. Hopefully you guys are aware of what Pig Latin is, but let's read the description. Translate the provided string to Pig Latin. Pig Latin takes the first consonant or consonant cluster of an English word, moves it to the end of the word, and suffixes an A. If a word begins with a vowel, you just add a way to the end. If a word does not contain a vowel, just add A to the end. Input strings are guaranteed to be English words in all lowercase. Alright, so let's look at a couple other examples. And before we do that, let's bring this over to our editor. Ooh, that's a little bit too big. Okay, so California, there are three criteria. Begins with a vowel, doesn't begin with a vowel, or has no vowels. So this one has vowels. Vowels are A, E, I, O, U. And because the first consonant cluster, or the consonant in this case, is just C. So C moves to the end and we add a A to it. So K. So this becomes California K. California K. Paragraph, the first consonant is the P. Aerographs pay. Aerographs pay. Glove, the consonant cluster in this case is this, because the first vowel from the beginning is the O. So we grab all the consonants before that, and this goes to the back with the A. So of glay, algorithm. So this one starts with a vowel. So we just add way to the end. So this is algorithm way. That's pretty simple. Another vowel, 8-way, simple. Swartz. So this one's pretty confusing. The consonant cluster before the first vowel is this. So this becomes arts sway. And rhythm, there is no vowel here. So we just add A to the end, rhythm A. So that's pretty simple. So we have three criteria. I would say the easiest one is this. If it doesn't contain a vowel, just add A to the end. Or if a word begins with a vowel, just add way to the end. So what I'm gonna do to solve this is I'm gonna handle this case first, if it begins with a vowel, and then handle this case if it doesn't begin with a vowel, and finally I will consider the situation where it begins with a consonant or a cluster of consonants. So let's begin here. Erase that for now. I will first define an array of all the vowels. So this will be a constant value, meaning we will never manipulate this variable. So I'm gonna typically for constants like that, we use all caps. Now I'll say vowels, and this will contain an array of all the vowels. O, U. Again, because we're never gonna manipulate this, we're not gonna add or erase any vowels in the near time future. So that's why I'm using a capital case for this. Now let's take care of this case. If a word begins with a vowel, you just add way to the end. So how do we grab the first character of a string, the 0th index of a string? So I'm just gonna extract that out here, and I will say first character is just gonna be string at 0. Now that we have the first character, we could test to see if that is a vowel or not. So one way we could do this is this. If first char is equal to A, or first char is equal to E, do all of that for vowels, but that's pretty tedious. And we're not putting to use this vowels array. So in order to use that, we could use one of array's methods called includes. We could say if our vowels includes the first character, so this will become true if our first character is contained within this array. So for example, in our example here, first character is C. Is it contained in here? Does this include that? No. So then this will be false. However, if it did contain it, for example, algorithm here, then it will be true and go inside this if condition. So if it includes that, then we know that it is this situation here. We just add way to the end. So we're just gonna return the string added with concatenated with way at the end. So we'll have fulfilled this criteria. Now, normally you would think one way to do this is to else if and do our second criteria. But because we are returning inside this if we were to go inside here, we will never reach the codes below this. So we don't need another if condition. So here we'll just assume that this has been taken care of. And now we will test this situation. If a word does not contain a vowel, just add a to the end. So how do we check to see if this string doesn't contain any vowels? So one way to do it is loop through each character in the string and check for each one. So let's do that. I'm gonna define a new variable. It's gonna be a Boolean variable, and I'm gonna say its name is has no vowels. So this will be a Boolean variable, and I am gonna assume in the beginning that it doesn't have any vowels. True. And because we may change it later, when it does have vowels, I'm gonna use a let keyword instead of const, and we are gonna loop through this string str using the for of loop, not const, for const character, or C for short, of string. And we are gonna say if, similar to this, if vowels includes C, meaning if C is a vowel, then this can't be true. It does have vowels, so this has to be false. So if that's the case, we're gonna set has no vowels to false. And instead of just constantly going over the loop, if we find our first vowel, we could just break out of this loop so that we don't waste time going through each of the other characters. And the way that we do that is use the break keyword. That way we break out of this loop once we found our first vowel. And again, I am checking to this one. If a word does not contain a vowel, just add the word a to the end. So if has no vowels, if this indeed turned out to be true. So again, technically what I wrote here is if this is equal to true, but because it's a Boolean itself, we could just do it like this, because that will either be true or false. So if that is true, then we will have return a string plus an a at the end. All right, so now we just have the hardest part, which is this condition here. It takes the first consonant or consonant cluster of an English word, moves it to the end of the word, and suffixes an a. So we have to loop through our string again and find the first consonant or the consonant cluster. Pretty much find all the words or all the letters until we hit our first vowel. So I'm gonna declare a variable in the beginning that we're gonna build up. It's gonna be a string of all of our consonant clusters. So I'm gonna say let consonant cluster be equal to an empty string. And then, so it could be one word, it could be one letter, or it could be many letters, many consonants. And I'm gonna do a for loop for let I will use a for of loop, just like here, const c of string. And we can say, as we loop through this, if vowels includes C, that means that we have hit our vowel. So we want to break out of this, and keep this in mind. We want to know the index of our first vowel. In this one, our first vowel is this one, is the A here. And the reason why we want to keep the index of this is because what we want to return is strip the first consonant clusters out start from this index, go to the end, and then add this along with A at the end. So we need to somehow grab the index when this is true. Now, the unfortunate thing about a for of loop is we don't have access to the index. So I'm gonna replace this with a typical traditional loop, for loop. So we're gonna say that I is 0, I is less than string.length, I plus plus, and I will just define our iterable variable here, const c is equal to string at I. So that's easier to work with. So if vowels include C, then break, and before we break, we are going to say we want to keep track of the index. So we will say let first vowel index is we're gonna assume that it's 0 in the beginning, but here, once we get here, we are going to say that the first vowel index is I, and then break out of it so that we don't continue. Otherwise, else. So we could either have an else here or we cannot, because we have this break. If we fulfill this criteria, we will never go into this else. So we don't need that else. We can say if it doesn't have this, then we're still in our consonant. So we just have to add to our consonant. So the way that we're going to do that is consonant cluster plus equals our character, like so. So we should, if we coded things correctly, we should have our consonant cluster, and we should also have our first vowel index. So now we got to do some string manipulation when we return. And what we're going to return is move the consonant cluster back. What we want is a substring of our string starting at our first vowel. So the first one is a start index, and that is our first vowel index. We want it to go to the end. So starting from here, we want to grab it to the end. So we're not going to provide an optional ending index. And after this, we're going to add a concatenate the consonant cluster. Whoops. Consonant cluster. And after that, we're also going to add AY to the end. So if all went to plan, this should work. Let me console log the result to this. So again, this starts with a C, so this will fulfill this, the third hardest criteria, because it starts with a consonant. And we should get back consonant K, consonant say, or however you may say that. Consonant say, so that seems to work. Let's grab this over. Make sure that Freecodecamp likes it as well. Run the tests. There we go. Now, as always, we're going to be doing some refactoring. So one thing that I could tidy up is, let's see, this whole part right here. So here, to check to see if it has no vowels or not, we have to loop through all of this string and look for our first vowel if one exists. So there's another way to do this. Let me do it right here. No, I will do it right below this. We can do if we are gonna split our string, which is a string, and make it into an array. We want to split up all the characters of the string into each element in an array. Split, in the way that we do that is we just split it with an empty string. That way, if we were doing this consonant example, then we will have an array of C as a 0th index, O as first, N as second, and so on. And the reason why I want to do that is once we have split it, we could, because now it's an array, we could use one of the array methods. And the one that I want to use is every. So what this is testing for is we provide a function inside. This is a function where what is looping through is all the elements as a parameter. So I'm just going to call that C for each of the characters that we're looping through. And the result of this every method is going to be true or false. So we're seeing whatever condition I put in here, does every single element in this array fulfill that criteria? So what criteria am I talking about? We want every character in our string to not be a vowel. So if vowel includes C but not includes C, meaning if this whole thing becomes true, then we know we are dealing with a string without any vowels. So if that is true, then I'm just going to return this right here. And then we could get rid of this part. So that's slightly better in my opinion. Let's try to make this a little bit more concise. So again, concise is not always better. And in the examples I'm going to show you right now, it probably isn't better. And I don't recommend you doing this. I just want to show you guys more than one way to do this. So one thing we could do is, I mean, this is pretty stupid, but instead of using this first character variable, just replace that instance with the string 0. We only use it once anyway, so I don't think it's not that bad to use string at index 0. So we could do that. Another thing that we can do is clean this part up right here. And what we can do is, this is gonna be pretty nasty, but I'm gonna split. So again, if I'm down here, if my code gets to down here, that means it included a vowel, meaning the first letter was not a vowel, and also all characters were not a constant, meaning there were some vowels in there. Then we're down here, so we could correctly assume that these two cases are not true anymore. And so now I want to deal with this case. I want to grab my first consonant cluster. So instead of doing this loop, what I could do is get my string, split it to an array, splitting each of the characters, and then join that back. I'm sorry, let's not do that. You could split it not to every character, but I want to split it by the vowels. And the way that we do that is we can't really do like A or E like this, because it doesn't accept OR operators inside the split. However, it does accept regex. So we could do, again, regex are regular expressions. It pattern matches strings. So we can do, regex are always encapsulated between two forward slashes. And we will say we want to split it by all characters that is either A, E, I, O, U. And then join it back. Let's see what that gives us. I'm gonna console log all of this. And we will store the result of this, because that's result, and console log the result and see what we get. We get nothing, and the reason is the example that we're using is not the third case. The third case would be California. Rhythm doesn't have any vowels. And I'm missing a parenthesis here. All right, so we get back this nasty thing. So the reason why I did this is I am just interested in the first consonant cluster. What I mean by that here Notice my first one is C. And as a matter of fact, I don't need this join. So let's just console log that. And we get back this array, this nasty array, separated by the vowels. So it's not that enlightening with this example, but let me show you this one, where we have a consonant cluster in the beginning. Then notice that our consonant cluster is the first index of this. So we can say consonant cluster is gonna be the first 0th index after we split it by the vowels. So now that we have the consonant cluster, we gotta first also grab the index after our consonant cluster. We gotta grab this index like we did here, because we want the substring of everything after that. So how am I gonna grab that index? And what I can do is, this is gonna be pretty nasty, and I'm just gonna return this string substring to grab the index. We don't have that variable handy right now. However, I know that this index, for example, this index is gonna be equal to the length of this. So for example, the length of this consonant cluster is 4. Now, what is the 4th index of this string? 0, 1, 2, 3, 4. If our example was California, our consonant cluster is just C. The length of that is 1, and the first index of this is the first vowel. So we can do substring starting at our first vowel index is going to be our consonant cluster, the length, and then we could do the same thing here. Consonant cluster plus A, like so. Let's see if that works. Archway, so that seems to work. That's good. Let's make this a little bit more concise. And what can we do to do that? I don't think we need to have this variable here, because we are doing things with it here and here. However, although I would argue this is not necessarily cleaner, we could use Es6 string interpolations for all of this. So let's do that. Instead of string plus way, we could do using backticks, $sign string, and way. Was it way? Yes. And for this one, string backtick and A. And for this one, I don't want to erase it because I might forget. Backtick, string substring that, and then another variable like so, and then A at the end. So, not the prettiest thing that I have seen. However, it does make the code a bit more concise, although that, again, that's not necessarily a good thing. Let's see if that works. Yep, that works for this example. Now, a couple more things that we can do is typically we define our consonants like this, things that never change outside of the function. So we can move this out here. The reason why we do that is when this function is called, we don't want to declare this constant over and over again every single time we call this. If it's outside the function, it will just be made once and that's it. But in order for us to do that, we have to change this to an arrow function. Actually, in this example, we don't have to, but I don't want to go into the reason of that right now. So I'm gonna do something so nasty, something that I will never approve if someone try to do this at my company that I work at. However, to quote unquote make this a bit more concise, we can use a ternary operator to handle all these cases. Do I want to do that? No, I don't want to do that. However, I will show you guys. So I need this guy first. So let's put that here. And then I'm gonna, these are 3 if conditions. We could just do this. Return, if this is true, return this. Or if that's not true, and if this is true, and as a matter of fact, I think this makes it a little bit cleaner, if it can be cleaner. Now, if this is true, then return that. Or if none of those are true, then we know we are dealing with this situation here, like so. I don't know why this is not allowing me to do that. I know why. Come on now. I see. Okay, so I guess if I made this a little bit smaller, yeah. I don't know why it doesn't like having this down here. Oh, there we go. Okay, so this essentially does the same thing. We have a ternary operator here. If this is true, return this, else if this is true, return that, else if if none of those are true, then just return this. And the reason why I brought this consonant cluster up here is because I want to write this way. Let's see if they like it. And they do. Hey, thanks for joining me again in this Freecodecamp algorithm. Tomorrow, we are going to be doing search and replace. So please stay tuned, subscribe if you haven't, and I'll see you guys tomorrow.